Next topic is beats. Beats is formed by the superposition of two waves of the slightly different frequencies moving in the same direction. If suppose we take two sound waves, one is S1 written as A cos omega 1 t and another is S2. This is the A cos omega 2t. Then the net displacement by the principle of superposition is given by S1 plus S2. This will be equal to A cos omega 1t plus A cos omega 2t. A is common, remaining is cos omega 1t plus cos omega 2t. Using the trigonometrical formula that cos c plus cos d is equal to 2 cos c plus d by 2 cos c minus d by 2. Here this omega 1 suppose it is c and omega 2 is the d. So this is equal to 2a cos c plus d, that is omega 1 plus omega 2 by 2 into t, and cos c minus d, that means omega 1 minus omega 2 by 2 into t. Let's suppose this omega 1 plus omega 2 by 2 is omega a and omega 1 minus omega 2 by 2 is omega b. Therefore, we can write it is 2 cos omega a t into cos omega bt. Here omega a is equal to omega 1 plus omega 2 by 2 and omega b is equal to omega 1 minus omega 2 by 2. We have already stated that omega 1 and omega 2 are slightly differ. This means this omega a, which is the sum of the frequencies, will be larger, and omega 2, that is omega b, it is the difference of the two frequencies, this will be smaller. So we can say omega a is very greater than omega b, and omega 1 minus omega 2, which is the difference of the frequency, it will be much lesser than the individual frequencies. Also, omega a is omega 1 plus omega 2 by 2, and because omega 1 and omega 2 are slightly different, therefore it is approximately equal to omega 1 or omega 2. Therefore, the resultant displacement can be written as 2a cos omega bt. This term is the amplitude of the resultant, and the term cos omega at, which is not differentiable from omega 1 and omega 2. And this amplitude of the wave vary according to the frequency omega b. And because amplitude has the angular frequency omega b and intensity is proportional to a square, therefore intensity will have the frequency 2 omega b. Hence, we can say that beat frequency equal to 2 omega b, and it is equal to omega 1 minus omega 2 using the relation omega b equal to omega 1 minus omega 2 by 2. This is the angular beat frequency. Hence, beat frequency will be equal to 2 nu b, that is equal to nu 1 minus nu 2, or we can say it is the difference of the frequencies of the two waves superimposing when propagating in the same direction. Let's do some problems. First question is, two sources of sound placed close to each other are emitting progressive waves given by y1 and y2. An observer located near these two sources of sound will hear the sound of number 1 beat frequency and number 2 the intensity between the waxing and waning. First part is we have to find the beat frequency, and we have already discussed that beat frequency between the two sound sources will be nu 1 minus nu 2. Here y1 is given for sine 600 pi t. This 600 pi t is omega 1, and another sound is y2 equal to 5 sine 608 pi t. Here 608 pi is omega 2. So now omega 1 is equal to 600 pi, and omega is, we know that it is 2 pi nu, and because angular frequency is omega 1, so we write it 2 pi nu 1. It is equal to 600 pi. Pi and pi get cancelled, and from 2 we will cancel it 600 by, now it becomes 300. So nu 1 equal to 300 hertz. Similarly, if we compare, omega 2 is 608 pi, or 2 pi nu 2 is equal to 608 pi. Pi and pi get cancelled, and on cancelling 608 by 2, it is 304. So nu 2 is equal to 304 hertz. Therefore, bit frequency will be 3, because we are taking the difference. So it is 304 minus 300, that is equal to 4 hertz. Second part is intensity between the waxing and waning. Amplitude of the first wave is 4 and second wave is of 5. So maximum amplitude is A1 plus A2, that is equal to 4 plus 5, that is equal to 9. And minimum amplitude is A1 difference A2, that is equal to 4 difference 5, that is equal to 1. So I max by I minimum equal to, because intensity I is proportional to square of amplitude, therefore I max by I minimum will be equal to A max square by A minimum square, and it is equal to 9 square by 1 square, it is equal to 81 by 1. So this is the answer.